Hello and welcome everyone to this new video of our Pandas playlist. So today in this video we are going to start with the arithmetics on Pandas series and data frame, and we will see some conditional filtering method to filter data from our series and data frame objects. So the objective for today's video, first we'll start with looking at some basic arithmetics like addition, division on series and data frames. Then we'll see how to filter data from these data structures. Okay. After that, we will see how to sort the data based on index or based on values. And in the end, we will see some very common methods like unique and value counts, which are used, which are very helpful in Pandas. So let us start with first series and scalar operation. So here you can see I have a series, and 0, 1, 2 are the index, and these are the values 10, 20, and 30. If I do plus 3, so 3 is an integer and this object is a series. So each of the element in each of the value in our series will be added by 3. So I will write 0, 1, 2, and the values will be added by 3. So 13, 23, and 33. So we will get a new series, and the index will be the same as this series, and each of the values will be added by 3. So you can do this operation with any other operand, like any other operator like multiplication, division, or any other that you know in Python. All right, so this is very simple operation between series and scalar. All right, let us try to do this in our code. So first I will import the pandas library, and I will create that series, and I will name this s1. So I will write pd dot series 10, 20, 30, and I would like to print this. So this is our series S1. If I write S1 multiplied by say 3.14, so each of the elements will be multiplied by this number. If I write S1 modulo 4, so each of the elements when divided by 4, what remainder is left we will get here. So 2, 0, and 2. All right, so this was between series and scalar. Now we will see the operation, same operation, plus, minus, division, multiplication, but this time between two series. So here are two series, and say for example I want to multiply these two series. So what will happen here is that the indexes here will be same, and each of the corresponding values will be multiplied. So 10 will be multiplied to 5, you will get so 10 into 5 will get 50, then 20 into 7 will get 140, then 30 into 9 will get 270. Okay, let us try to do this in code. Very simple thing. Again, I will create another series. So first we have this series S1. I will create another series S2. Okay, I will not create any series S2. Say if I just write S1 minus S2. Okay, S2 is not defined. Sorry, S1 minus S1. So this series will do subtraction with itself. Okay, so we'll get 0. If I write S1 multiplied by S2, sorry, S1 multiplied by S1. So 10 multiplied by 10, 100, 20 to 20, 400, and 13 to 30 will get 900. So this was operation between series when we have same indexes. You can see here we have 0, 1, 2. Here also we have 0, 1, 2. Okay. Now what happens when we have indexes different this time? So here you can see we have index 0, 1, 2, and here we have 1, 2, and 3. So series operation, the operation between series, one thing you have to keep in mind that this occurs label wise. Before also when we did operation between these two same series, the operation was label wise. That means this series was not adding the first value to the first value of the series. No, it was adding the value with label 0 to the value of value with label 0 in this second series. This was S1, this was also S1, and so the same labeled values were operated upon. Okay, so same thing here. You can see, but here we have 0 label. For example, this is S1, this is S2. Here we have this label 0, but we don't have a label 0 here. So what you have to imagine is that this S1 will intermediately add a new label 0. Sorry, this S2, this doesn't have label 0, right? So it will add a new label 0, and it will just write na. Okay, so in the final series, say for example if we add these two series, what we'll get is, so this 0, here we have this label 0, but here we do not have any label 0. So by default, this label 0 will be NaN. Okay. If yeah, so this label 1 we have 20, and we have label 1 which is 5. So label 1 will be added to the value label 1. So for this we have 10 plus 5, sorry, 20 plus 5, 25. Similarly, for this label 2 we have label 2 in both the series, so we get 37. Now in this series S2 we have label 3, but in S1 we do not have a label 3, so by default it will do 3, and it will just write NaN, and in the final result we will have NaN. So 9 plus NaN will result in NaN. Okay. And if you want to replace this default behavior, we can do this addition operation by this method, s1 dot add s1 sorry s2, and I will write fill value is equals to 0. So what I was replacing here with NaN will be replaced with value 0, and addition will take place. So for example, here on label 0 I have 10. On label 0 in S2, this NaN will be replaced with 0. So I will get 10 plus 0 is equals to 10. So I am not getting here NaN anymore. Okay. Same for this label 3. I had this in S2, but in S1 there was no label 3. So this will be replaced with 0. And 9 plus 0, I will get 9 in this new series. So this thing is that this operation takes place label wise, and if you want to replace the NaN values, you can write fill value is equals to whatever you want to fill your value with. Okay, so the thing is that the labels that are not common to both the series will be treated as NaN or the fill value that you provide here. Okay, and you will get all the labels that you have in total. So in this we have 0, 1, 2, in this we have 1, 2, 3. So in total we have total unique labels, we have 0, 1, 2 and 3. Fine. Let's try to do this in code. I have this series S1. So I will create another series S2, and I will write pd.series, and I will add 5, 6, 7. Okay. Or it was 5, 7, 9. Okay. Then I will print this series S2. So this is our S1, this is our S2. I forgot to change the index for S2. I will write index is equals to 1, 2, 3. So now if I add S1 and S2, S1 plus S2, so the index 0 is not in S2, so it will be replaced with NaN, and NaN plus any number will result in this NaN value. And if I write S1 dot add S2, this will also give me the same result, but here I can use fill value, and say is equals to 30. So this 0 is not common to both series S1 and S2. So if series S2 doesn't have 0, it will be filled with 30, and 30 plus this 0 labeled 10 will result in 40. Okay. So you can also use some more methods like s1.mul, and this is for multiplication. Here also you can use fill value. You can use div for division. You can use sub for subtraction. So this will do S1 minus S2. Okay. And to check out more about these methods, you can visit the official documentation of Pandas. All right. Now we'll come to the operation between data frame and scalar objects. So here you can see I have a data frame which has 3 rows and 2 columns A and B. If I do this data frame df minus 2, so each of the element will be subtracted by value 2. So I will get a new data frame, 18 and 28, 98, 198 and 298. All right. So each of the elements will be subtracted by this 2. All right. So this is simple operation between data frame and scalar. So I have created a data frame that I showed you on the board. So this is our data frame df. I can do df multiplied by 8. So each of the elements will be multiplied by 8. If I do df divided by say integer division 20. So yeah, any operator you can use that you know in Python. Fine. Now operation between data frame and series object. You can see here I have that data frame. and here we have a series. So a operation between a data frame and a series, if I add these two series, so what you have to keep in mind is that this index for the series will act like columns, and you have to imagine that this series has been transformed to a new data frame where the labels have become columns and the values will be 1 and 2, and this will be duplicated this way downwards to match the shape of this data frame. Okay, so this data frame and this data frame can be added element wise. All right, and the index will also be 0, 1 and 2 by default. So these two data frames can be added, and I will get this data frame. Say I've used here a minus sign. So if I do a minus sign, so from column A, this one value will be subtracted for each of the values in this column A, and this 2 value will be subtracted from each of the values in column B, and I will get this data frame. So let us try to do this. Yeah, so this is our series S1, series 1. So this is our series and this is our data frame, and if I write df plus series 1, so for column A, we have one value, so 1 will be added to column A values and 2 will be added to column B values. Okay, and here I have another series S2, series 2. This time you see that here I don't have A and B as labels, I have 0, 1 and 2. So let us see what happens if I do operation between this data frame and this series call. Okay, sorry, series 2. Yeah, so series 2 has labels 0, 1, 2, but in data frame we don't have labels 0, 1, 2. So this operation happens something like this. Here you can see this is A and this is this is a data frame df, and this is our series 2. Now as I said earlier that the labels for the series will become column values, and the values 1, 2, 3, 1, 2, 3, and this will be replicated downwards. 1, 2, 3 to match the rows for this data frame. Okay, now this data frame has columns AB and this data frame has columns 0, 1, 2. So they clearly doesn't match. So what will happen is an entirely new data frame will be created which has columns A, B, 0, 1, 2, and all the values will be nan, as you can see here. Yeah, here all the values are nan. Why this happened? Because none of the column indexes matched. So that's why we get this empty data frame. Now we can do see, for example, if I have you can see that I have here 0, 1 and 2 data frame, and I want this series to match not the columns but the row indexes for this data frame. So I have 0, 1, 2 here, I have 0, 1, 2 here. I want to match these, and what I want to do is from the 0 row I want to subtract value 1, and from the 1 row I want to subtract this value 2, from this row 2 I want to subtract this value 3. So this is column wise operation, and to do this we have to use a method called df dot sub and this series, and axis is equals to 0. Okay, so axis is equal to 0 tells to do the operation column wise. So this is called column wise operation because this series is not replicated this way but this way, 1, 2, 3. So you have to replicate column wise. So 1, 2, 3 again to match the size of this data frame. Now you can see we can do operation with these two series, and although we don't have column names A and B, column names A and B here, but by doing this axis is equals to 0, we can do this operation column wise. So that means for row 1 we are subtracting 1, for row 2 we subtract this 2 and this 3. So in the end we get this data frame. So 1 is subtracted from this row, 2 is subtracted from this row, and 3 is subtracted from this row. Okay, and by default if we do just say this is df, this is our series, if we just add these two series, by default the behavior is the labels of the series will become column names. Okay, and we will get this type of operation. So I will create a new series S2. I have created this new series S2, right? It doesn't have column names A and B, but our data frame df have column names AB, and it has indexes 0, 1 and 2. And say I want to write df plus series 2. So this by default we know that it will not match the row index, so we will have to write df dot add s2 and axis is equals to 0. I think, yeah, axis is equals to 0. Sorry, I have to write df dot series 2. Okay, so axis 0 means column wise, axis 0 means column wise. Okay, so axis 0 means column wise duplication. That means this series will be extended this way, 1, 2 and 3, to match the shape for the data frame. All right, and if we just simply added, say, df dot add series 2, and we didn't specify the axis, so by default the behavior is axis is equals to 1. Axis is equals to 1 means row wise, so row wise is axis is equals to 1. And what is row wise? Row wise means this series is duplicated by each row, and axis is equals to 0 means column wise. What does column wise means? Series is duplicated by each column. Okay, all right. Now we come to the operation between data frame and a data frame. So here, as you can see, we have two similar data frame, df, this is also df, and say we want to multiply these two data frame, we will get a new data frame where each of the corresponding values will be multiplied. Okay, so 10 will be multiplied with 1, 30 will be multiplied with 3, 20 will be multiplied with 2, 40 will be multiplied with 4. Now, a very important thing to keep in mind here is that this data frame also does index based operation. So basically data frame has two indexes, row index and column index. So you can see here this value 1 is actually accessed using row 1 and column A. This value 4 is in row 2 and column B. So for row 1 column A we have value 1. So here also we have row 1 column A and we have value 10. So corresponding value based on the indexes, row index, column index, we will get element wise operation. Now another case, if we take here, in this data frame you can see the values are still the same, but what you see here is that this time this has row 1, row 2, this has row 2, row 3, and all columns also are not aligned well. This has A and B, this has B and C. So this so what we get here is unique rows. When we combine both the data frame, we have row 1, row 2 and row 3. So these are the three unique rows, and columns also, here we have A, B, here we have B, C. So in total we have 3 columns. Now what will happen is, for row 1 and column A we have value 1, this is df1, this is df2. For row 1 and column A we have value 1, and for row 2 we don't have row 1 here, so this will be replaced with nan. Okay, here we will get nan for row 1 column A, and nan plus 1 will result in nan values. So you can see that most of them are nan. That is because very few or just one value is matching for both the data frame, that is row 2 column B. So for row 2 column B I have 4, and say I am doing addition operation, row 2 column B I have 10. So 10 and 4 will be added, I will get 14. So this is the only index that matches between these two data frame. Rest all are will be nan. All right, so this is the only common index between these two data frame. So we will get this data frame like this. All right, let us try to do this in code. You can see I have these two data frame, df1 and df2. So I'll want to print this. This is df1, this is df2. If I do df1 multiplied by df2, so corresponding elements will be multiplied. And how? By the index labels. Okay, row and column both. Say if I change this data frame to df2, and say I change the column names B, C, and index also I would like to change 2, 3, and I would like to print this. So I have changed the labels and nothing else. And now if I add df1 plus df2, so I will get all the nan values. Only this value I will get as 14, because For row 2 and column B, this is the only index that matches in both these data frame. Okay, the rest all are NaN because we don't have these indexes in either of the data frame. Either we don't have in data frame 1 or we don't have in data frame 2. Okay, so this is a labeled wise operation that happens both in series or data frame. We could do here something like df1 dot add df2, and if we specify fill value, say is equals to 0, now we'll get sorry, df2. Now you can see there are still two NaN values. Now why are they? Because row 1 column C, row 1 column C is not present in any of the data frame. We have row 1 but we don't have row 1 C here, and for row 3 column A we have row 3 in this data frame, but we don't have column A. Okay, so they will still be NaN even if we have provided fill value 0. Fill value is 0 provided only for those indexes which are in any one data frame but not in other. So for example, row 1 column A, we have row 1 column A in data frame 1, we don't have row 1 column A in data frame 2. So for this will be replaced to 0 and 10. Let me print this df1 and I'll print this df2. So for df row 1 column A, I have 1, but there is no row 1 column A in df2. So this will be filled with 0, and I will get 1 plus 0, 1, and similar for all the indexes. Okay, all right. Now we come to conditional filtering. Now we can filter the data from our data frame or series based on condition. For example, I have to show you this in Excel workbook I have created here. So as you can see, I have this data in tabular format. If I select all this data, go to this data tab, and here in this I select filter. Now you can see I can filter on these columns. Say in product, I want to select only widget B and widget C. Okay, so this is the data in which in product I only have widget B and widget C. Say for example, in region I want to select north, only the north region. So this is filtered only to the north region. This is a amount column, and this is basically a numeric column. I can do number filter here. You can see I can do equals, greater than, less than, so something like this. For example, greater than say 1000. Okay, so only those data will be selected for which the amount is greater than 1000 and the widget is C and the region is north, only the north. Okay, so this type of filtering is also possible in our data frame. Let us try to do this. So this is our series S2 and this is our data frame DF. Let us try to do this first on the series S2. So series S2, and I will do square brackets. Inside this I will define condition. So it can be say S2 greater than say 7. So only this value 9 is greater than 7, so this is selected. If we check what is this S2 greater than 7, sorry, it is a boolean series. Okay, you can see this is t-type bool, so this is a boolean series. Okay, only the value that is true will be selected. If I pass this boolean series to here square bracket, we can select the data. We have already seen in the previous video how to select, access and modify the data in series and data frame. Okay, we could also use s2 dot location. That also works the same way. Okay, you can use that, there is no problem. Say s2 is equals to 7, so only that data will be selected where the value is 7. All right, so let me keep this here. Yeah, so if I use any of these relational operator, greater than, equal to, less than, equal to, not equal to, here say for example greater than, equal to, or say less than, equal to 8. So all the values which are less than, equal to 8 will be marked true and other will be marked false. Now this is a boolean series, and I can pass this boolean series. So this is our series S into a square bracket, and I can pass this boolean series, and another series I will get only those values which are true. Okay, I can use dot location also and pass this boolean series inside this. Okay, so yeah, the same thing here. S series s less than equal to 8, so we can see we have 5 and 7 less than equal to 8, so we'll get this. We can combine multiple such boolean conditions using operators like and, or, not, XOR, like that. So here, as you can see, I have, so this first is a boolean series which is s greater than 5, so this will be false, true, true, true. And this is another series in parentheses. You can see s modulus 2 not equal to 0. Basically this is to select odd numbers. So 5 is an odd number, 7 is odd, 9 is odd, and 10 is not an odd number, so this will be false. And this AND operation is a boolean AND. That means if both the conditions are true, this will give true. So this two boolean series will give another boolean series that is ANDing of both. So first will be false because true, false will be false. Both are true, so we'll get true. Both are true, again we'll get true. True, false, we'll get false. So this is the final boolean series that will access the data here. So false, true, true, false. That means these two values. Logically, what it means is give me those values in this series S, which are greater than 5 and they are odd. Okay. So these are the values that are greater than 5 and they are odd numbers. Okay. Same thing we can do with the data frame also. Here you can see I have a data frame df, and I can pass inside df, inside the square bracket, I can pass the boolean series. Here what I've done is the boolean series is created like this. So df and sorry. So this df square bracket in stock, this actually selects a series. This is the series. This is the series. So you know that this type of indexing is used to select the column from a data frame. So I'm selecting this column, and this column is basically a series. So yeah, in data frame, one column is just a series. Okay. So I'm doing equal to true. So it will check where the value is true. It will just give me true. Okay. So only the true values will be selected in this data frame. Only those rows will be selected for which the in stock value is true. Okay. Let us try to do this in code. So I've already created that dictionary to create my data frame. I will just write pd dot data frame data, and I will store this in df, and I would like to print this df. So this is our data frame. If I write df dot location, I can also use a location square bracket, or I can simply use square bracket also. Okay, you can use whatever you like. Okay, and here I have to pass a boolean series. Instead of a boolean series, I can also pass a list, say true, 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 and false. So this will also work. So that means I have to select first two rows. Okay, so for now let us do that conditional filtering. So I will select, say, price column, and I will say give me all the product list. I mean, give me all those data rows in which the price is, say, for example, greater than 500. Okay, so this is the only product that is greater than 500, and I can combine it using a logical operator like say, for example, or. And let's say this time I select this another series, and this is in stock. Say it is true. So it says, okay, so here the error is that I have to close this into a parentheses. So this is very important. When you are combining two different boolean series, you have to enclose them into parentheses, and then you have to use that a logical operator between them. Now if I run this, so logically it means give me the product whose price is either greater than 500 or that product is in stock. Okay, so here you can see the price is not greater than 500, but this product is in stock. Here the price is also greater than 500, and this is in stock also. So or a logical or, if you know, it is true when either of the condition is true. Okay, to use the not condition, you will write df, say, price greater than 500, and you have to enclose this in parentheses. Then only you can write here this tilde. This means not df of price greater than 500. So it will invert that operation. So this time I will get all the products whose price is not greater than 500. This is also equivalent as saying less than equal to 500. Less than equal to 500. This is same. Okay. So you can combine various different logical conditions like we did here in Excel. If you remember, when we did say select only widget A and B, status is say pending. Like that, you can combine logical conditions to filter the data. Okay. Now we come to sorting the data in our series object. So here you can see I have taken that price series from the our data frame. Now to sort it based on index, I will write s dot sort underscore index method. Now you can see that this series has already in sorted order based on index 0, 1 and 2. So by default it is sorted, so it will not do anything. If I want to sort it in ascending order, so it's ascending order, I will pass this attribute ascending is equals to false. So now you can see that this index 2 comes first, then 1, then 0, and the values are also sorted with these labels. Okay, so they will have to remain the same. All right. If I want to sort based on these values, I will write s dot sort underscore values, and by default sort underscore index or sort underscore values are ascending. Okay. If you want to do descending, then we will have to specify this attribute ascending is equals to false. All right. So by default they are ascending, so sort underscore values. So by values I get this sorted order 25, 150 and 999. All right. Let us try to do this in code. This time I have this series s. If I write s dot sort underscore index, nothing happens because this is already sorted ascending by index labels. If I write s dot sort underscore index and ascending is equals to false, this time this will be ascending false, means descending sort by index, and to sort by values I write sort underscore values. Same thing I can do if I want to sort it descending order. Sorry, control ascending equals to false, so that means sort by descending order in values. Same thing with the data frame also. If I write df dot sort underscore index, okay, and I can pass that ascending equals to false here also, it will do that. If I write ascending is equals to false, this will sort by descending index. Instead of false I can also write 0 or 1, because in Python, if you know, true is treated as 1 and false is treated as 0. So sometimes you can write these boolean true false as 0 or 1. So if I write 1, that means ascending sort. If I write 0, that means not ascending, that means descending sort by index. Now here, let me go to here and clear this filter and go to data and sort. You can see it gives me sort by. If I write say amount, and here I specify say largest to smallest, that means descending sort on column. So this will sort the data based on the amount and descending sort. If I write sort again, you can see I can here add another column. I write say region, and it will sort it A to Z. All right. If you want to sort based on values, I will write df dot sort underscore values. It says it requires a argument by. So we didn't specify based on what we want to sort this data frame. Okay. So we will have to say, for example, I write price. So this data frame is sorted based on price, and by default we know it is ascending order. If say for example there is tie between two values, say df dot sort underscore values, and I can pass multiple column names. First I want to sort based on whether the product is in stock. Next I want to pass based on the price. So first this sorting is based on the in stock, that means ascending order first. So false 0 it comes first, then we have 2. So this column is sorted, fine. Now the price column, you can see in price column, if there was a tie between these two values, the smallest value will appear first. okay, because after you sort by this in stock, sort by price. Okay, when there is a tie between two values, you sort by price. Okay, so multi-level sorting is also possible here. We just have added two levels of sorting, and we can also provide separate sort order for both in a list. So in this second list that I pass, I can write 1 comma 0. It says to position argument, okay, ascending is equals to, yeah. So this one tells me to do descending sort on this in stock column. Descending sort, that means sorry, ascending sort on this in stock column, that means this false will come here, and then we will have the true values. And 0 tells to do descending sort on price column. So here you can see that 25 is coming first, then 99, then 150. Why? Because this price is sorted after this in stock column. So for false, we have this value. Okay, here we have two trues. Now the sorting will be based on the price. So that's called multi-level sorting. Fine. So we can use the same way, sort underscore index with ascending false, sort underscore values based on a column, and by default they are ascending. If you don't want to do ascending, then we'll have to provide ascending equals to false. Okay, here we need multi-level sorting. Okay, so and we can also provide different orders for each columns. Okay, now we come to two more methods, that is unique and value counts. This is our series S. If we write s dot unique method, it will give us total unique values in our series. This is our series. We have true, false, true. Now only there are only two values that are unique, true and false. Okay, so we will get a numpy array in which there will be elements that are unique in this series. Okay, so duplicate values will be removed, and we will just get a numpy array that has unique values. One more method, that is s dot value underscore counts. Value counts, what it will do is it will count that unique value. So we know that we have true and we have false, but this method will count how many true and how many false do we have, and this will be a new series whose index name is this the column or the series name that we are doing on. So we have two true values and one false. All right, so here is our series S. If we do s dot unique, so all the values are unique actually, so we didn't get anything interesting here. I think I have to pick df dot in stock. So this is our series, and if I use unique method on this, it will give us the unique values in our this column or the series. Okay, one column of data frame is actually a simple series. All right, if I do the value count in stock dot value counts, so it will count the total values for each unique values in our series. Okay, and this in stock that you see up here on the series is actually the index name of our series. Let's say I want to just give it a variable series, and I will print this series. And if I write series dot index dot name, so this is the name of the series that it gets. If I simply write s series dot index, so this is the index, true and false. If I write series dot values, we get the value 2 1. Okay, if I write s series dot name, its name is count. This is the name of the series, this is the name of the index of the series. All right, so here we end this video. I hope you enjoyed watching this, and yeah, stay connected to get more videos in this Pandas playlist. From next video, we will see how to clean and transform the data in our data frame objects, and we'll see more advanced method. All right, so we have made it to the end of this video. Thank you for watching, and I'll see you in the next video. Till then, keep learning.